Hello students, I welcome you back to my session. Myself Dr.T.L.Abinaya, working as Assistant Professor at School of Architecture and Interior Design, SRMIST. Today I am here to deliver a lecture on structural concept and applied mechanics. We are moving to Unit 3. Unit 1 and Unit 2 is already posted. You can check my previous videos. And in Unit 3 we are going to see about what is slab and what are the types of slab, and beam and types of beam, and column and the types of column and the failure pattern, and the thumb rule of column, beam and slab we are going to discuss, and the orientation, and about the steel structure and the Indian standard roll steel session and connection advantages and disadvantages. So these are the topics which we are mainly going to discuss in today's session. Moving to slab. When we take a slab is mainly made up of RCC, that is reinforced cement concrete. There are various configuration in RCC roof slab. That is, a slab is a structural element whose thickness is small compared to its own width and length. Slab are usually used in the floor and the roof construction according to the way the loads are transferred to the supports, beam and column. Slab are classified into two types, that is one-way slab and two-way slab. When we take a slab, that is reinforcement detail of the slab is done based on its support condition, and the slab is supported directly by the column is called as the flat slab. The slab is supported on the two sides, and bending takes place predominantly one direction only is called as the one-way slab. And the other hand, the slab is supported all four sides and bending take place in two direction is said to be a two-way slab. So there are two types of slab. One is like one-way slab and other is like two-way slab. You can see the one-way slab. So these are the example of the pictures is attached here. And what is one-way slab in the sense? The one-way slab which is supported the beam in two opposite directions. So the beam will be supported only two opposite directions is called as the one-way slab to carry a load along the one direction. If the ratio of the large span to the short span is greater than or equal to 2, the slab is to be defined as a one-way slab. When a slab is supported along any two direction, two opposite edges along by the wall or the beam is said to be a one-way slab. You can see the image. So there is a 4 column, but the beams are running only on the two directions, so not all the 4 directions. In such case it is known as the one-way slab. Two-way slab. The two-way slab is the slab which is supported by the beam on all 4 sides of the load or carrying along the one direction is called as a two-way slab. If the ratio of the large span to the short span is less than the 2, the slab is to be defined as the two-way slab. So you can see the two-way slab image. So there is a 4-side column. The beam is running all 4 sides is known as the two-way slab. So the main difference between one-way and the two-way slab is the one-way slab is supported by the beam in only two direction. The two-way slab is supported by the beam in all 4 direction. The ratio of the longer span to the shorter span is equal or greater than 2, but here in two-way slab the ratio of the longer span to the shorter span is less than 2 is called as the two-way slab. So the main reinforcements provided in only one direction is called as the one-way slab. The reinforcement in all the 2 directions is called as the two-way slab. In one-way slab, the reinforcement is parallel to the shorter direction, and the reinforcement parallel to the longer direction is called as the distribution of the steel. So these are the main 2 difference between the one-way slab and the two-way slab. And when we take a beam, what is beam? Beam is a horizontal member of the structure carrying a transverse load. The member that are slender and the support loading that are applied perpendicular to their longitudinal axis is called as the beam. The beam is the structural element that is capable of withstanding a load primarily by resisting its bending. And beam is the structural member which is span horizontally between the supports and carry a load which act as a right angle to the length of the beam. So the beam is always a span horizontal between the supports and carry a load of its right angle to the length of the beam. And this is the image. You can see the beam span and the load will be acting on. Generally a beam is subjected to set a external force and two type of internal force, and the external force are loaded applied to the beam and direction to the load from the support. The two type of the internal force are the bending moment and the shear force. Types of beam in construction. So mainly the different types of beam are classified based on the following conditions, such as based on the support condition, based on the construction material, based on the section, based on the geometry, based on the equilibrium condition, and based on the method of construction. So based on this parameter, the types of beams can be determined. Types of beam according to the end support. So according to the end support, we can call this type is the simply supported. You can see the simply supported always mentioned in the triangular one. On the top of the triangle, the beam will be supported. So this is known as the simply supported beam. The simply supported beam is supported at both end, and one end of the beam is supported by the hinges support, and other end will be loader support. So the roller support, they are mentioned in the circular one. This support allowed to horizontal movement of the beam if the beam types undergoes the both shear stress and the bending moment. So this is a fixed beam. You can see from the wall the beam is the fixed. So both the end is the fixed end. The fixed beam. The fixed beam is also known as the built-in beam. It's a rigid fixed on the both the end, meaning it cannot rotate or transit to the support. This type of beam is provided the greater resistance to the bending and deflection compared to the simply supported beam. Moving to the characteristic of beam, the both end are rigidly fixed, and it has the two direction force and two reaction movement at the support. Unfixed beam experience less deflection compared to the simply supported beam. This develop the internal movements, reduce the bending stress, and used in the structural requiring the high stability, such as bridges and continuous frame. And advantages: reduce the deflection efficiently and can carry a higher load than the simply supported beam and provide the greater structural stability. And the disadvantages of this simply supported beam, it's reduce the high fixed end moment, and which may lead to the crack if not properly designed, and difficult to construct due to the rigid connection, and require the precise calculation of the moment and the deflection. Continuous beam. So this is a continuous beam. You can look into this image. The continuous beam, both the beam will be fixed into it, and there will be an internal wall or column which can be added as a partition. The continuous beam is the structural element that exists over multiple support. So it will run over the multiple support without the hinges or breaks, and improve the long distribution and reduce the bending moment compared to the simply supported beam. The main characteristic of beam is it can support by the 3 or more support, and more economical than the simply supported beam. It reduces the bending moment, and it also the bending moment will be reduced as it's continuously supporting on the one stretch. And the advantages of reduce the bending moment and lesser material required, and more stable and can carry a higher load with the less deflection, and improve the durability and less risk of the failure under the dynamic loads. Cantilever beam. So moving to the cantilever beam. Cantilever beam is the structural element that is fixed. One end will be fixed, other end will be a free end. So it is capable of carrying a load overhanging from the support. So the key character in this sense is the support condition, one end is fixed and other end is free. Free to move. And the long load, the point load, uniformly distributed load, and varying load. So these are the types of load it can be carrying. And the shear force and bending moment. And maximum shear force occurs at the fixed end, and maximum bending moment will be also on fixed end, and gradually reduces at 0 at the free end. And the application where this type of beams can be applicable in the sense: balcony, overhanging roof, and traffic signal and signboards, and aircraft wings, and bridges and towers. Overhanging beam. So overhanging beam also is quite interesting. When you see the cantilever beam, it can be without any support. But here you can see in between. If you want to extend more than 3 meter, or if you want to extend more than 10 meter and all, you need a in between you need a support. So that is known as the overhanging beam. Overhanging beam is a beam that exits beyond one or both the support. It is the combination of the simply supported beam and the cantilever beam. The key characters: the support condition, the one end has the pinned or the rolled support. The beam extends beyond one or both support, forming a cantilever section. The types of load it can be capable of carrying: a point load, uniformly distributed load, or varying load over the span and overhanging portion, and shear and the bending force. The maximum shear force occur near the support, and the bending moment varies, and it's occur in the support and the overhanging end. The overhanging portion behave like a overhanging beam with the middle section, and behave like a simply supported beam. Application: the balcony slab, roof projection, bridges with extended end, and also the walkways. Stress beam. The stress beam, in the sense, a beam reinforced by the stress rod, are formed of the straight are the pieces joining by the stresses. The stress is the network of the bar that does only experience the tension and the compression. So this will have only the tension and compression, no bending moment and shear force. This is made possible because of the bar is connected to each other using only the pin joint, which leads to a broad pivot. Based on the construction materials. Based on the construction material, the beams can be constructed using a reinforced concrete beam, steel beam, timber beam, and composite beam. So usually the beam will be made using a reinforced concrete beam for the RCC and RCC folded plate structure and all. So reinforced concrete beam, it is constructed from the concrete and reinforcement. You can see the steel rod has been connected and stirrup has been used to tie all together. And this is the steel beam. So the single solid steel plate is used as a steel beam application. And timber beam. So earlier in the timber structure and all, they will use a timber as a beam to carry a roof load or slab load. So this type of beam is constructed using a timber used in the past, but its application is significantly declined now. So now they are not using much timber. Composite material. The composite material are constructed from two or more different types of material, such as steel and the concrete, and the various valid cross section has been utilized. You can see there are different types of material has been used. Based on the cross section shape, the several cross section shape of the beam is available and used in the different types of construction structure. This beam can be constructed from the reinforced concrete, steel, and the composite material. The reinforced concrete cross section shape includes the rectangular beam. You can see the single reinforcement section, double reinforcement section. So these are the cross section of the beam. And the T section beam, I section beam. So inside they can use a single steel plate to have more rigid beams. So they can use as a T section and I section. So both the sections can be used. So this type of beam is the T type can be mostly constructed the monolithical with the reinforced concrete slab. Sometimes the isolated T beam are constructed to increase the compression strength of the concrete. Added to that, the T beam can also be constructed according to the requirement of the loading imposed. When you take a I section, I beam is a structural steel beam which I and the H shape in the cross section, which is widely used in the construction due to its higher strength to the weight ratio. These are the steel cross section shape included. So there are various steel beams cross section shape is available. So the cross section shape offer superior advantages in this given condition compared to the other shapes. So there are square, rectangular, circular, I, T, H, C, and tubular are the example of the beam of cross section shaped can be constructed from this based on the geometrical pattern. So there are straight beam, the beam with a straight profile, curved beam, the beam with the curved profile, and tapered beam, so the beam with the tapered cross section. So these are the three different geometrical pattern where the beams can be used based on the equilibrium condition. Statistically determined beam and statistically indeterminate beam. There are two types of beam. The beam is called determined beam if it can be analyzed by the basic equilibrium condition. So the support reaction can be found by using a basic equilibrium conditions, and these conditions can be summation of all horizontal forces 0, the summation of all vertical forces 0, and the summation of all moment is 0. So example is simply supported beam and cantilever beam as the determined beam. And when you take a indeterminate beam, so which cannot be analyzed by using a basic equilibrium condition, or known as the statistical indeterminate beam. So the end reaction find out using basic equilibrium condition with the combination of other condition like strain energy method and visual work method. Example, continuous beam and the fixed beam. Based on the method of construction, they cast inside a concrete beam. So usually when you have a normal rectangular beam for the RCC frame structure and all, they will do the beam construction inside. This type of beam is constructed on the project site. So foreman initially fixed with the fresh concrete is poured and allowed to be hardened. So this load will, then the load will be imposed. So this is the normal. Usually they will construct for normal duplex and individual houses and multiple floor building. And precast concrete beam. So this type of beam is manufactured in factory. So they will measure the dimension. So all the beams. So wherever when you taking your entire construction, wherever you have a beam, the beam will be measured and the depth and width and everything. The reinforcement detail, everything is given, taken by the civil engineers, and they will do and they will precast in the factory, and they will bring it to the site, and they will use a heavy cranes and all to lift the beam. So lifting the concrete elements is quite difficult, so they will lift all the elements using cranes and all, and they will fix it. So that is the precast concrete. So usually the precast concrete beam will be used for the RCC folded plate, so not for the RCC frame structure. So when they have a RCC folded plate, they will use this kind of precast concrete. Consequently, the quality of the concrete of the beam will be greater, and various cross-section shapes can be manufactured, such as, so whichever shape you want, in that particular shape they will do the reinforcement, and they will do the construction. Thank you. That's all about today's session. So in today's session we have discussed about the slab. So when we take a slab, there are two types, that is one way and two way, which we discussed, and we have discussed about the beam. There are multiple types of beam which we discussed, and based on its construction material, based on its shape, and based on its equilibrium, we have discussed the different types of beam which can be used in the RCC structure. Okay. Thank you all. See you in the next session. Thank you. Bye bye.